Hello and welcome to my graduate project presentation for CSCI E29. My name is Phil Karpovich, and today I'll be demonstrating my project of building a number of models to predict malicious websites and then deploying those models to Azure Machine Learning Studio. CSCI E29 was offered during spring 2018 through the Harvard Extension School, and this slide is just showing the instructors with Ninad as the professor or the instructor and the TAs underneath him. The purpose of this project is to build a number of models based on a Kaggle dataset for malicious or non-malicious websites. I'll show you where the link to that dataset is later, but after building these models, I wanted to then deploy the best of those to the Microsoft Azure Studio cloud-based service, which can then be consumed as an API through applications or other websites down the road. So for this project, I used the Pandas, NumPy, and sklearn library for Python. I also got the dataset from Kaggle, as I mentioned before, which you can see at this link. My notebook URL is located at my GitHub account, which is here. And finally, if you also want to try using Microsoft Azure ML Studio, you can sign up for a free trial at the below link. So before getting into my demonstration, I just want to give a quick overview of what Azure ML Studio is. It is a service offered as part of the Microsoft Cloud Platform, Azure, that lets a user build and deploy machine learning models. You can actually iterate over the model building experience and test and verify models before actually deploying them. Once the models are deployed, though, you can then consume them through a RESTful API, and you can pass in values to predict, and you'll get out either a regression or classification output based on the model that you built. So, for my code, pretty standard ML project. Started by importing in my dataset, obviously. Saved it locally from the Kaggle website, but there it is. I then did a little bit of feature manipulation. The biggest thing here was expanding out the car set and server variables into dummy variables. There was a very distinct number of values that these two records had, or these two features had, so I actually expanded them out to binary 0 and 1 dummy variables. I did a few more things to tweak the data a little bit. I won't get into too much here, but feel free to look through my code when you have the chance. One thing I will note, though, is I did actually end up dropping a few variables, such as URL, the who is reg date and who is updated date fields, just because they didn't really fit nicely into my analysis, and as we'll see later, it didn't really impact the end results too much. Also, one thing I did was take a look at the malicious and non-malicious websites. In this case, malicious being represented by type of 0. Sorry, non-malicious being represented by type of 0, and malicious being represented by type of 1. And just kind of seeing if there were any features that stood out. This wasn't used going forward, but this would be a good basis for feature selection if we needed to pare down the features we're using. I then got into the actual model building piece of this, where I used mainly naive Bayes, random forest, KNN, and then logistic regression models to see which could have better predictive power. One note on the random forest is I did want to use an ensemble method, so the random forest was kind of my shot at that to see what it can do and how powerful it can be. I also split my model building into two different steps. The first step was using data just from the first 15 features of our data frame. So as you're here, we have features 1 through 15. And then later on, we get into all the features, actually. So I want to see if there's any difference between the two. So one thing we'll note here with just the first 15 features is that naive Bayes did a terrible job of picking out or predicting these values. That's mostly, in my opinion, due to the fact that we just have so many more 0 values anyway, so it's giving a lot of false positives. But interesting. For both logistic regression, or KNN and logistic regression, though, we're getting around a 93% accuracy, or score, which is okay. But what's really interesting is the random forest actually gave us a very accurate model back. So I then went back through and added in all the rest of the variables and ended up getting both a perfect model with random forest and logistic regression. This is kind of strange to me, and I think there's something funny happening here where Kaggle made this as a dummy data set, possibly, because it just seems too good to be true, honestly. So, taking a look at this, it seems like random forest or logistic regression are great. So I'm actually going to go and deploy these to the Azure Machine Learning Platform, as we'll see here. Really quickly, this is a workflow that you drag and drop these different building blocks onto. So you have website, CSV, that's the data source I used in my Python script, execute Python script, and then split data, attach that split data to a model, train your model. This is the initialization for a model. You can then score the model and evaluate your model to see the values you got back. So you can kind of see the confusion matrix here. And one thing to note about this, though, because I'm going through it really fast, but one thing interesting is you can actually drop in Python scripts here. So for example, I pretty much took the exact same feature manipulation lines in my Jupyter notebook and dropped them right in here. Once you have this model, you can then actually deploy it as a web service, which will allow you to pass in JSON objects and then get back JSON objects with your predicted value. And the documentation is already available through the Azure platform, so it's pretty cool and pretty easy to quickly know how to implement this into an application or website. So this was a very, very high-level overview of what Azure Machine Learning Platform can do and how you can import models into it. My sense, though, this is a pretty cool tool to use when it comes to actually productionizing models, as you can abstract away the model prediction aspect from the actual Python code underlying it. Thanks, and I hope you found this informative. Have a good day.